and we're going to throw this one on YouTube as well. So section 1.1 is safety. I'm going to do that on another day. I wanted to jump right into some of the sciencey stuff. So section 1.2 is called investigating matter. What I've done on the front page, these are vocabulary words that by the time we get to the chapter quiz, you want to know what these mean. I'm not going to define them right now, but when you're studying, you want to be going, oh, I should know what all of these mean. Hopefully, they'll just naturally come as we go through the lessons. So we're going to be talking about boiling point, conductivity, density, element, mass, melting point, state, and volume. And let's start here. So chemistry. What are we going to learn? Well, we'll talk about why water flows but ice doesn't, why fireworks are different colors, talk about the structure of an atom, how to use the super cool periodic table, which is essentially the alphabet of the universe, why table salt is really called sodium chloride and how to name it, why you can thaw and refreeze ice, but why you can't somehow reverse cook meat and make it raw again. Few important points for all of you, though. Almost everything in chemistry builds on what we did the previous lesson. And so the message I want to give you is do not fall behind. If you are stuck, well, first of all, I would say rewatch the video lesson on YouTube because that can help. I'll show you how that works later on. But I'm around most days after school, come in as soon as you can. Do not put things off for like 2 weeks thinking it will get better. It won't, but it will get better if we correct whatever it was you were stuck on, and then all the other dominoes will fall into place. So it's hard to get caught up in this unit. A lot of kids have told me this is probably the toughest unit. Probably. I think it's one of the coolest as well. And I did say you are going to want a cheap, crappy, basic calculator starting in the next couple of days, and you'll see we'll be starting to do some subtracting and adding of 2- and 3-digit numbers in our heads, or you can use a calculator for it. So let's begin. Matter. Yeah, turn the page. We're good? Matter is anything that has mass and volume. Matter is anything that has mass and volume. Damien, am I writing big enough for you to read in the back corner okay? Yeah? Okay. You're about the furthest away from the screen, so I always ask. Okay, I said mass, I said volume. I better explain what those words are. So mass is the amount of matter in a substance, often measured in grams or kilograms. Can I abbreviate kilograms with kg? Okay. Worth saying, and I'll say it several times again, I tend to try and abbreviate stuff. Feel free to come up with your own abbreviations in your notes. The only place I don't use abbreviations is on tests because I want to make sure the marker knows what the heck I'm talking about, right? But feel free to come up with a system that works for you. So mass is the amount of matter in a substance, usually measured in grams or kilograms. Volume is the amount of space a substance occupies, often measured in liters, spelled R-E in Canada. No, but I'm a proud Canadian. It is Z, not Z. The only country where this is not true is the US. As of this time last year, there were 2 countries on Earth, Liberia and the United States, that hadn't gone metric. Liberia went metric last year. The US is the only country that hasn't gone metric, and that explains a lot about the US. Anyways, they would measure in pounds, and they would measure the volume in gallons or cups or pints or ounce. It's all stupid. Review of grade 8. So in grade 8, you learned about the particle model of matter. Hopefully you learned that all matter is, well, what is all matter made of? It begins with the letter A, small little particles. What do we call them? Atoms. Small particles called atoms. And it turns out that there are tiny, tiny spaces between those particles. Hopefully you learned last year that these atoms, that these particles are always moving, and the faster they move, the hotter the object. The slower they move, the colder the object. This is what explains how objects are hot or cold. It really is on a, I was going to say microscopic level, but smaller than microscopic. On a quantum, on an atomic level, it's how fast the particles and the atoms are moving back and forth. When you heat something up, all that happens is they move back and forth faster. When you cool something down, what happens is they move back and forth slower. And the other thing that hopefully we learned is the particles are attracted to one another. Hopefully last year you learned 3 states of matter. Does anybody remember the 3 states of matter? Yep.
Liquid, solid.
Okay, so liquids and solids and gases is correct. Of those 3, my friend, which one is a definite constant shape and volume?
Solid.
Yep. Solid. Something that's solid has a shape and a size, and if you walk away, that doesn't change. Which one of these has a definite volume? It takes up space, but an indefinite shape. It'll fill a container, but on the bottom of a container. Right there. Begins the letter L. Okay, so liquid, if I have 5 liters of liquid, I have 5 liters of liquid, but I could put that 5 liters into different shaped containers, and it will take on the bottom shape of the container. I'm still stuck with the volume, 5 liters. And the last one, well, what's left? Gas. That has an indefinite shape and volume. If I release some gas into a container, it will always just spread out evenly. It will take on whatever shape the container is. It won't just sit on the bottom like liquid. It'll fill up the entire container. And if I take that same amount of gas and move it to a bigger container, it'll fill up that bigger container. It'll just be less and less dense in doing that, but it has an indefinite shape and volume. Is that okay so far? Coming back to you. It's been a while, I know. I'm going to come back to that video a bit later, I think. Are there more states of matter than these 3? Yep, there are. Those are the big 3 because those are the ones that you see all the time. Every time you take a breath, you're breathing in a gas. Every time you drink water, you're drinking a liquid. Every time you eat food, you're chewing a solid. But another cool one that I always have to mention is plasma. The sun is made out of plasma. So some people think the sun is a big hot ball of glowing gas. No, it's a big hot ball of glowing plasma. What the heck is plasma? I'm going to tell you an explanation which you may or may not understand yet, but by the end of the year you will understand. Plasma occurs when you have an atom and it's in a situation where its electrons are ripped away and all that's left is the nucleus. There are other cool and neat states as well that we can create in labs or that occur inside stars or in strange locations in the universe, but for now, solid, liquid, gas. A chemical change is a change in matter that occurs when substances combine to form new substances. Great example is baking. You combine a bunch of liquids, you add some heat, and holy smokes, you get a solid cake. Cool. Explosives are an example of a chemical change. During an explosion, the chemicals contained in the explosive are often combining with the oxygen and other gases in the air, and you get boom. So, can you pass it behind you, Aiden? Thank you, thank you. We're going to talk about kinetic molecular theory. That's too long a phrase. What would be a good abbreviation for kinetic molecular theory? You know what? Let's put in brackets here KMT. And I'm okay if you use that on a test, I will know what you're talking about. Okay? So in theory, you learned this last year, but I'm assuming you've forgotten it all. Kinetic energy is the energy of motion. Kinetic energy is the energy of motion. Kevin, heads up. Catch. Bad toss on my part. Was that ball moving? Yeah. It had kinetic energy. I gave it some when I tossed it. Can you grab it for me? And try and toss it back without hitting anybody in front. Thank you. Was the ball moving? It had kinetic energy. Anything that's moving has kinetic energy, which means, since I said on the subatomic level those particles are moving back and forth, they've got some kinetic energy too. The fact that all the particles in every solid, every liquid, and every gas are always moving means they have kinetic energy, the energy of motion. And the kinetic molecular theory, or as Aiden has christened it, the KMT, explains what happens to matter when you change that kinetic energy, when you add or remove kinetic energy to the particles. It says this. First of all, it says all matter is made up of very small particles, the smallest of which are atoms, but molecules and compounds and things. It says there's empty space between the particles. And it says that the particles are constantly moving. You said that already, Mr. Dueck. Yeah, I'll tend to repeat myself. Sometimes I find that repetition helps. Repetitiveness helps kids learn. Repeating things can sometimes work. See, I did that 4 times. Anyways, you're teenagers. You need to hear things more than once. So, in a solid, the particles are so tightly packed together that they can't move around freely. All they can really do is vibrate a little. They have very little kinetic energy. What about in a liquid? Well, in a liquid, the particles, well, they're farther apart. And they can slide past each other. That's what makes a liquid behave like a liquid. Sloshes. So what do you think? Do you think they have more or less kinetic energy than a solid? What do you think? If they can move easier, and if kinetic energy is the energy of motion, what would make sense?
More.
More. Okay? In a gas, particles are very far apart, and they move around very quickly. They have even more kinetic energy. So if we summarize this, the more kinetic energy the particles have, the faster they can move and the farther apart they can get. So it leads to a question. What's the easiest way to change the kinetic energy? Yeah, add or remove heat. And you know this intuitively. You have learned that when you freeze water, what does it turn into?
Ice.
Solid.
Solid.
In fact, when you freeze most things, they become more solid. You have learned that when you heat things, they become sometimes liquid or sometimes even gas. And we can do this in a lab to the ultimate extremes. We can go all the way down to what's called absolute zero, which is the coldest temperature that we can get to. It's when the very atoms themselves stop moving. We can do that in a lab. And you can get hotter and hotter and hotter. You can get hotter than the inside of the sun. Nuclear bombs get way hotter than the inside of the sun. I don't know what the upper limit is on heat. Maybe there is one, I don't know. But just keep adding energy. It'll get hotter. So let's summarize. If energy is put into a substance, so if we add energy, it changes from what to what to what? You're right. Okay. Solid to liquid to gas. Good, Lena. Oh, and if you remove energy, it goes in the opposite direction. Why? Because what moves faster? Begins with the letter P. Okay, particles move faster. And because the particles are moving faster, what happens to the distance between the particles? Gets bigger, gets smaller, or stays the same? Gets bigger. I'm going to say increases, fancy word. And because now they've gotten further away from each other, normally they're attracted to each other, but because they're further away, the attraction force between them decreases, and now they're more willing to slosh if they're liquid, or float if they're gases. And the reverse, Lena, the reverse is true. If you remove energy, it would go from gas to liquid to solid, and the spaces would become closer, and they would end up not moving as much. Open your textbook to page 20, please, to see a lovely example. So continuing on, I gave you this diagram here, and what I said is you should know all the terms that describe the changes of state. So these are the different terms. You ready? Read along with me from this picture. It's also in your textbook. When we go from a solid to a liquid, looking at this chart, what do we call that? Melting. What about when we go from a liquid to a solid? What do we call that? Solidification. Now you can put in brackets the slang term for that. We call it freezing. Right? That's really what you mean when an object goes from a liquid to a solid, but the fancy name is solidification. I think you can remember that solidification becomes a solid fairly easily because the word solid is in the word. Okay? And melting, I think you all know that word already. It's some of the other ones that are a bit more obscure. Let's go from a liquid to a gas. What do we call that? I'm going to hope that evaporation is also part of your vocabulary. I'm going to hope that you all know what the word evaporate means. What about when we go from a gas to a liquid? We call that condensation. You see that every time you, on a cold day, go to a window and you go on the window and you see the water vapor that comes out of your lungs condense into a little cloud on the window or on the mirror. That's condensation. I'm hoping you know the word condense, but that may be a new word. The one I suspect is new to all of you, unless you remember it from grade 8, are the two on the left. When you go from a solid directly to a gas, skipping the liquid stage, what do we call that? Sublimation. I haven't come up with a dumb, easy way to remember that word. If I do, or if you come up with a dumb, easy way to remember that word, great. Sub means lots of stuff to me. I'm working on it. Now, what about from a gas to a solid? It's called deposition, a deposit. That one I can sort of wrap my brain around. By the way, that's what rust is. Rust is gas, oxygen in the air, combining with iron and becoming a solid. Okay? It doesn't turn liquid in between. It goes straight to solid. And ice, ice, if you leave it in the freezer, your ice tray, and you come back in a month and you notice how the ice cubes have shrank, they have sublimated. They have gone from a solid directly into a gas without actually going into a liquid. That's why ice cubes shrink in the freezer. So those happen. On your chapter quiz, you can expect me to give you this diagram, this exact diagram, with lots of those words missing and say, fill in the missing words. Okay? Or my usual hint is this. I say, I like this question, I like this question, I like this question, I like this question. Why would I say that many times? Because you're going to see it in the future somewhere. Probably want to make a little note. Or not. Okay. So I wrote down here, you should know all the terms that describe the changes of state. Expect a question like this on chapter and unit tests. Note that freezing point and melting point are the same. In other words, what temperature does water melt at? It's an easy number. 0 degrees. Okay? What temperature does water freeze at? 0 degrees. It just depends on whether you're adding kinetic energy or taking away kinetic energy. Okay? So, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. Can I have you two temporarily go together? And Aiden, I'm going to quiz you. Here's what I wrote. Can you all... well, let me pause the video here, first of all. Well, let me see here, actually. Hang on. We're going to temporarily pause here. Can you look at the assignment that I gave you? Right now, I haven't quite finished the lesson, but you are capable of doing this first page here. I've talked about all this, and you should be able to handle this page here. Now, there's a few words in this vocabulary that you might not know. Can you all look at page, let's say 17 in your textbook, please? I'm just going to pick a page at random. Going to teach you how to speed study. Okay? If you're trying to speed study, if you're doing vocabulary, this textbook does almost all of its vocabulary words in bold font. In other words, you can usually glance at the page and spot inside the paragraph a vocabulary word. Chemical change is a vocabulary word. Can you see it? It's pretty obvious. So that's a good way when you're studying, when you're doing the homework and you're saying, hey, I don't know what this word is. You can probably just flip a couple of pages. It will always say what textbook pages that we are in. So you should be able to handle this page. Okay? Next class, I'm going to get to this particular stuff and this particular stuff, although if you want to get a head start, you can. On the very last page, I have included the answers. Do not be a foolish young person and just copy the answers. Tests in my class are worth 70%. The homework is worth 30%. If you want to cheat on the 30% and flunk the 70%, you've got far bigger issues than doing homework. I had a kid last year who got perfect on every homework assignment. He would finish it every time in 5 minutes. He was just copying the answers, and then he was flunking every test. Don't do that. Don't do that. I want to be able to give you the answers so that you can mark your work and see if you've done it right or see if you've done it wrong. I want to trust you with that. Don't be one of those people who just copies the answers. I'll know. And then if I have to, I'll rip the answers off of your copy and have other people have it. Don't make me do that. For any questions there? Yep. We're going to continue with this next class, so if you don't want to be overwhelmed on the weekend, you probably want to try and get these 2 pages done in class, but I don't think you need to work on them as homework tonight unless you know that Thursday, Friday, and Saturday you have lots of evening sports things planned, then you might want to do them tonight. That's a long answer. That's basically what I'm really saying is, when is it due? Get it done as soon as you can in your schedule. Does that make sense? Okay, and I got one more cool video to show you.